Hello everyone, we've got question 5 here, so of 2024, paper 1 for Edexcel. And it says the function f is defined by f of x is equal to 2x minus 3 over x squared add 4, where x is a member of the set of all real numbers. Show that f dashed of x is equal to that expression there, where a, b and c are constants to be found. So we've got a nice instance here of the quotient rule. So we've got our quotient, where that's our u and that's our v. So I've just written down the quotient rule. Now remember, the good thing, which seems to be a very common theme in this particular paper, is that just about everything is in the formula booklet. So here we have the formula booklet, the formula booklet's version of the quotient rule. It's written in function notation. So we have f dashed of x times by g of x minus f of x g dashed over g squared. Now I've written that in u and v notation just because I prefer it. So the quotient rule is going to be u dashed v minus uv dashed over v squared, where y is equal to u over v. So our u is 2x minus 3, so therefore our u dashed is 2. Our v is x squared add 4, so our v dashed is 2x. And then we're just simply subbing into the formula. So our u dashed is 2, there's our v, minus our u, and our times our v dashed over v squared. Now we just expand the brackets and collect like terms. So 2 times x squared is 2x squared, 2 times 4 is 8, minus times 2 is minus 4x squared, and a minus times a minus makes a plus, and that's going to be 6x. 2 take away 4 is minus 2, and then we've got 6x plus 8. So that is part A done. We found out what A, B and C are. Our A is minus 2, our B is 6, and our C is equal to 8. Part B then, it says, hence, using algebra, find the value of x for which f is decreasing. You must show each step in your working. So let's have a look at this. So something's decreasing when f dashed of x is less than or equal to 0. So I've set it equal to 0 in order to find out where the critical regions are. So our equation is from here, minus 2x squared plus 6x plus 8 equals 0, okay? And then I have times everything by a negative, minus 1, so the signs have all changed, and I've divided by 2. I factorised, and I found out that my solutions are 4 and minus 1. Now, we need to be careful here because this original quadratic is this kind of shape. It's upside down. As you can see, I mistakenly drew it the wrong way earlier. But it's upside down and it's decreasing. So we were interested in the region where the function is less than 0. And the function is less than 0 here. So in other words, when x is greater than 4, or here, in other words, where x is less than minus 1. So that's one way to approach it. There is another way to approach it. What I could have done is I could have used inequalities. So this is now another approach to that same question. So if I'd have used inequalities, what I would have said is minus 2x squared plus 6x plus 8 is less than 0. And then when I multiplied everything by the negative, I would have reversed the direction of the inequality. So I would have been looking for where this quadratic is greater than 0. And I think actually this approach kind of makes more sense really. Then I divide everything by 2 because it's an equation. So x squared minus 3x minus 4 is greater than 0. Factorise it again, so I get minus 4 and x add 1. And then that gives me my solutions of x is equal to 4 and x is equal to minus 1. We're looking for the region where this is greater than 0. So that means it's going to be this region here, which is x is greater than 4, or this region here where x is less than minus 1. So that's our solution for if you're going to solve it that way. And I think arguably that second approach makes more sense. I hope you found that helpful, and I'll see you in the next video.